Hello everyone, I'm LAW Cheuk-Him from the Hong Kong University of Science and Technology. Currently a Year 3 undergraduate student majoring in mechanical engineering. As a student member of the Hong Kong Institution of Engineers, I'd like to share my participation in an HKIE activity last year, which was a technical webinar on the new generation of power system of the MTR in Hong Kong, organized by the Electrical Division of HKIE. The webinar was delivered by Mr. Raymond Tam and Mr. Anson Chen, who are both very experienced engineers from the MTR. Let's talk about the background of the current power system of MTR. As mentioned by the speakers, nowadays the power output of MTR is close to 250 megawatts, which is equivalent to the power sufficient to supply almost 200,000 people for their living in Hong Kong. The ultimate power source is supplied by CLP and HEC. This power source is then stepped down and rectified by transformers and rectifiers. The power system of MTR is divided mainly into two subsystems, namely the high voltage power and the low voltage power. The high voltage power is used for high intensity work such as the overhead cables of trains, and while the low voltage power is used for low intensity work such as the shops at many stations. Besides transformers and rectifiers, a lot of electrical equipment, including the switchboards and circuit breakers, are also utilized to allow precise control, easy maintenance, and ensure the safety of the entire power system. This power system of NPR has been put into services after different construction phases since 1979, when the earliest sections of Queen Tong Line, Tsuen Wan Line, and the Island Line were established. During decades of non-stop services, the electrical equipment has been replaced many times. So why does the current power system have to be replaced? Well, the regular maintenance of the power system is no longer effective, and with the extension of existing rail lines and the construction of the new ones in the near future, the power system capacity has to be increased. Also, with the advancements in technology these years, electrical equipment with better designs is available. Therefore, MTR is dedicated to redesign and upgrade the power system and develop a new generation. First of all, with advancements in technology, more powerful transformers are available, making it possible to simplify the three voltage levels to only two. Besides, the other electrical equipment is also replaced with more advanced designs, which are more reliable, safer to use, easier to maintain, and at the same time, these designs often consume less energy and occupy less space. The entire upgrade project takes almost a decade and involves a collaboration of different engineering firms and workers. One of the major challenges that the project brings is that the upgrade of power system should not interfere with the normal operation of MTR, because MTR has been playing a crucial role in the public transport system for so many years that now it is impossible to stop its service even for only one day. Therefore, engineers have to come up with a plan that allows them to implement the new generation of power system and remove the old one without affecting the normal operation. In fact, there have always been two sets of equipment, with one running most of the time while the others stand by. Engineers can then upgrade one of them without affecting the normal operation, then switch the power system to the new one. After that, they upgrade the remaining old set of the equipment. I think this is a very clever way of upgrading the power system without affecting the normal operation. Moreover, the construction and testing work are often carried out during the nighttime when the MTR is closed, so that the normal operation during the day, especially the peak hours, is not affected. The speakers also talked about how the engineers utilize new construction technologies in this project. In the webinar, he showed us how they used 3D space sensor and cameras to simulate the environment inside the machine rooms of different stations and computers, and then model on the computers the way to pack the new equipment inside the limited space. At the same time, they have to be aware of the safety issues related to the location of the equipment. I believe this must be a very tough task for those engineers, but they eventually managed to finish the work. Personally, I take the MTR a lot as it is a vital part of the public transport in Hong Kong. But I guess not many passengers have the deep understanding of the underlying power system. All these details we can see are indeed the hard work of Hong Kong engineers. Through this technical webinar, I learned a lot about the power system of MTR and also its upgrade project in the recent years. I also appreciate all the effort that many Hong Kong engineers have made in this project, making the lives of every Hong Kong citizen so convenient with a reliable, safe, and efficient mass transit railway system. That's all for my sharing. Thank you.